I'm not allowed for the first hour. Yeah, sure, of course, of course. Okay, so yeah, if you can teach it, then I can't go over it. I'm sorry, but afterwards, if you need help on it, I can help you with that as well. Yeah, it is frustrating, but for right now, you can just do the session as it is, and then I also have a practice test and a study guide as well. So I'll probably send this afterwards. It's two separate documents, and you'll go over it later in the session. Yeah. So SmartWorks, you guys have some of that. I had some people ask questions and things on that. So if you need any help with that, please don't hesitate to ask me. I've had multiple students already say, like a lot of students have asked me like questions on SmartWorks alone. So if you any have questions with that or like labs, because I know some of you guys have your lab final coming up. When I had it, I thought it's not that bad, so don't worry about it. It's not that terrible. Also, your life will not be terrible or ruined because you do poorly on something. So don't be too scared. And then after your test, Monday your finals begin, and then on May 10th you have your last test, which is 10:30 a.m. to 12:30 p.m. and that's your last final. So that's the agenda for the rest of the semester. And then for today, we're going over 8.6 precipitation reactions, 8.7 oxidation reduction, and then 21.1 because she didn't go over that. I can't really go through it. I wish I could because it's actually not that bad. But it's unfortunate that you guys can't learn it until tomorrow. And you already have SmartWorks due, so like I don't understand, but it is what it is. Okay, the schedule. So from 2 to 3, we're gonna go over, it's probably gonna be less than that now because 21.1 we're not doing. So we'll do over like those sections. Then I have a Kahoot, but it's not just like regurgitation, it's actual practice test. So the solubility rules. I'll send her an email because I thought someone would have sent something by now because I thought it's too much to memorize. So we'll see. I'll see. I'll talk to her privately probably. So I'll do that, don't worry. And then, so the Kahoot practice test is actual practice test, so you will need paper and pen or something to write it out. And I think it's really good practice. It has like neutralization, acid, base, and like all this other stuff. So please participate in that if you can. And then I'll have like a little like break in between. And then we'll have a Kahoot Q&A. I'm planning to do the Kahoot, and then with every question that ends, I'm gonna go over that question. So I don't want to wait till the very end because then you guys are gonna forget. So, and then after that, for 15 minutes, is any questions, comments, or concerns? Is that okay? Any questions right now on the agenda? Are we good? And I'll talk to her about the solubility rules. Yeah, that's so weird. I don't know. Because usually teachers allow formulas for that. I'm hoping maybe she'll put it on the exam, but I don't know. Yeah, are we okay? Yes? No? I don't know. Yes. Okay, great. All right. So warm up. Okay, the strength of ion-ion interactions blank with increasing charge and blank with increasing ion size. So what happens when the strength of ion-ion interactions increase, the charge of it? What happens? Can anyone tell me? What happens when those ions interact with each other and the charge increases? Does anyone know like what happens in that case? Does anyone want to guess? Oh, it goes up, it goes down, it gets stronger, it gets weaker. Does anyone have an idea? Perhaps? Again, like any guess is fine. I'm not gonna like goes up stronger, maybe stronger. Okay, yeah, that's correct. It's actually more, I would say more just increasing, but you can also stay stronger as well. So it would definitely increase. And then what happens with increasing ion size? Does anyone know? What happens when you increase, because you already have the strength of the interactions, right? What happens when you increase the ion size? Does anyone know? Does it go up? Is it weaker? Is it stronger? Can anyone tell me what that is? What they think? Does anyone know? Weaker? Okay, do we have any other guesses? If you have a wrong answer, it's fine. Weak. Okay, anyone else? Because some of you guys said stronger for the other one, right? Weak. Okay, yep, that would be right. You would decrease, so the strength of the interactions will go down. So you can see it's an inverse proportional relationship. So if you have two ions and they're interacting, and let's say the charge goes up, then you know it goes up too. But then if it's increasing ion size and just gets bigger, then it actually decreases the strength of the interaction. And then the next question, are group 1 cations soluble? How do you know? So group 1 cations, what do we think? Are they soluble or not? Yes, yes. How do you know? How do you know they're soluble? Can anyone tell me like how do you know, right? Because I mean, obviously you guys learned this. How do you know rules, law? Okay, all right. So I would say that as well. And specifically, what does that rule state? Does anyone remember what did that rule say? Does anyone remember specifically the rule? What it said? Because there was two other things that were in it, I believe. And I'll list those rules. Yeah, group one cations and also ammonium are also the first rule solubility, and then after that the second rule has to do with ions, and then the third rule is limited solubility, which includes usually individual elements and what the exceptions are with those. So speaking of chloride, bromine, like all of these, so all of these are compounded with each other. Are they soluble? If you were to mix and match Cl, Br, Ag, and I, would they all be soluble together or no? In the textbook. Yeah, I also have a picture on here if you want as well. So if you don't want to go in the textbook and do all of that, I have a photo on here as well. So are they, but just looking at this, okay, yeah. So chloride and like iodine, like with those, if you put those together, would they be soluble? Like any four of these, if you put it together, yes. Okay, so yes. Can anyone tell me why they said yes? Or if they said no, why would they say no? If you put any one of these compounds together, they would all be soluble? Yes or no? So yes. I have one response for yes. Does anyone else have an answer? You can just guess if you want to. If you don't know, you can just give your best guess. I don't know. Okay, anyone else? If you don't know the answer. There's an exception. Yes, exactly. Okay, so what's the exception here? Which is the one thing here that's the exception? Can anyone tell me? If there is one? What would it be? What was the exception? Does anyone know? If you don't know, you can also say I don't know, so it's okay. You don't know, okay. So with this, it's actually solubility rule number 2, because again, like I think most people haven't memorized it, but Cl, Br, Ag, and I, actually not all of these are soluble. Only Cl, Br, and I come off as soluble. Ag is the exception. That's why it doesn't work. That's why you have to memorize the solubility rules, or maybe if you definitely need to have it if you don't memorize it, because Cl and Ag, it's not soluble together, but ClBr is. So again, Ag is one of the examples of, the exceptions to the solubility rules. And speaking of LiOH, is that soluble or not? Yes or no? Is that it? And that goes with the solubility rule number 3. So can anyone tell me? Yes. Okay. Yes. All right. So can anyone tell me why? Why is that soluble or not? Can anyone say why? It's in group 1. Okay. Does anyone else have another explanation? Oh, he's soluble. And Li is the exception. So you're saying it's soluble? Because you said yes. So Dolores, do you mean it's soluble? Yes. Okay. So right explanation, wrong answer. So this is not soluble. LiOH is not soluble. And because again, it is in group 1 that is correct, but you're going off of, what's it called? You're going off of OH first because that's the ion. And that's what I meant when I said solubility rule number 3 says that OH has limited solubility unless, and then Li is apparently an exception, but I'm pretty sure it's not. So that would be no. And then what about fluorine? And that again, that one, fluorine is just another memorization one. So is fluorine soluble or not? Can anyone tell me that? Is fluorine soluble or is it not? In any compound actually, not just alone, but with like BrCl, anything. In any type of compound, is fluorine soluble? Yes or no? Again, if you don't know, you just guess and then give an explanation. I don't know. Okay. No, I don't know. Okay, anyone else have an idea? Fluorine. Yes or no? You don't know. Okay. So fluorine is not soluble. Again, I think this is just solubility rules. You would definitely need to look back on that one. And fluorine, that's just memorization. Anything with fluorine, for the most part, it's not soluble. Unless, again, like the few exceptions, but fluorine, for the most part, is not soluble. What about acetate? And that's an ion. Remember, it was like the CH3COO. Do you remember, guys? Remember that? For that ion, is that soluble? Yes. Okay, any other answers? So Samantha says yes. Do we have any answers from anyone else? Yes, too. Okay. And then anyone else? And then can anyone say why? Why is acetate soluble? What makes CH3COO a soluble compound or an ion? Why is that soluble? Does anyone know why? Can anyone explain why? Because it's a weak acid. Well, okay. Well, yeah, I mean, you could say because it is, it is an ion, so I understand what you're saying, but it's more because it's an anion. It's a part of the anions on the solubility chart. Yeah, yeah. Yeah, the gears started clicking right there, right? Okay. But yeah, acetate is soluble, and you could say because it is a weak acid, perhaps, but again, it's more just because it's part of the anions chart. Dissolvable. Yeah, soluble means dissolvable. And then precipitate is a blank form or product from a reaction solution. So what's precipitate? Like, how would you know when you look at an equation, if you had two compounds and you had it going to two products, how would you know which one is the precipitate? If you have like two products, how do you know which one's the precipitate? It's insoluble. Okay, and what is that? It's characteristic insolubility of what? Because you're on the right track. But what does the insolubility lead to? What is that? Does anyone know? Yes, no, I don't know. It's like, you don't know. Okay, does anyone else know? Solid. Yes, that's completely right. Yep. If it's, and you'll know, not because it says like solid immediately, but I'll have it in parentheses S, and that's how you'll know. And then that's your precipitate, and it also doesn't dissolve. So if you're writing your net ionic equation, you don't separate that one product because there's no reason to. Therefore, it'll always be part of the net ionic equation. Do we have any questions? We're all good on this side? I think it's not too bad, right? If you know the solubility rules, it's actually pretty easy. So are we good on this side? Yes? Yes, no, I don't know. Are we good? Like, we don't have any other, okay. To memorize, there is a chart in your textbook, I noticed, and I didn't notice this until today when I saw it, but there's like a little graph or something where it says like, oh, CH3COO, if it crosses like this, then yes, it's soluble, or yes, no, it's not. And there's like a little chart. I'll try to send it later when I have the email. And I'll send this all together, so you'll have that. But again, it's also in your textbook, so you can definitely visit that if you want as well. Okay, so those are the answers, in case you're wondering. And then, okay, so for this one, write the chemical formulas for the following compounds and then use solubility guidelines in tables 8.4 and 8.5 to classify them as either soluble or only slightly soluble in water. Okay, and this is the chart I was talking about, by the way, that you would either have to memorize or not. And I'll tell Dr. Kelly tomorrow during class of whether or not, and I'll send it in the moderator's chat so she can see it separately. Okay, so starting off, calcium chloride. Does anyone know, would that be soluble or not? Looking at rules 1, 2, and 3. Calcium chloride. Does anyone know? Yes. Okay. Any other answers? So Laura says yes. Anyone else? Yes, yes, yes. Okay, great, great, great. Okay, how do we know? How do we know calcium chloride is soluble? Yes, exactly. Yep, exactly. So chloride says right there, and there's none of the exceptions, right? Ca, it doesn't say cations or like anything or of the sort. So therefore, rule 2 proves that it's soluble. What about potassium phosphate? What would that be, soluble or not? Potassium phosphate. And phosphate is an ion, so please look out for that. Potassium phosphate, is that soluble or not? And what rule does that go with? Does anyone know what that would be? Potassium. Yes. Okay. 3. Okay. And then yes. Okay. Do you have any other answers? I'm getting yes so far. Anyone else? Do you have yes for anything else or no, or what else do we have here? Or maybe you guys are confused on the formulas. I don't know. Anyone else? Yes or no? If you have the wrong answer, you don't know, you can just write I don't know as well. Anyone else? Yeah, a little confused. Okay, so when you write out potassium phosphate, potassium is K, right? Phosphate is an ion, and that's represented by PO4. So we have potassium phosphate here. When you look at this, what do you notice first? What are we looking at here? Which element? Are we looking at potassium or are we looking at the phosphate? Which one's easier to look at? Potassium or phosphate? Yeah, exactly. The phosphate, right? So rule number 3 has phosphate right here, right? So and that's supposed to be limited solubility, right? So it already has it, so it's technically limited solubility. But then there's exceptions. Anything of group 1 cations, and K is a group 1 cation. So it's part of the exceptions, therefore it's soluble. Yep, exactly. There we go. Okay, what about iron 3 hydroxide? Is that gonna be, and this is a little harder, no. Okay, what rule does that go with, Akash? And then does anyone else have an answer? No, yes? What do you think? 3. Okay, and then anyone else have an idea? This one's actually really easy once you look at, you don't have to focus on the 3, by the way, like you just have to cross it out. It literally doesn't even matter. You're mainly looking at iron hydroxide. So does anyone else have an answer? Yes or no? Because so far we have no, right? But I want to make sure everyone else agrees. So, do all agree? I think no. Okay, no, because of rule 3 2. Yes, exactly. Hydroxide, as I'm sure you guys all memorized at this point, hydroxide is just OH, right? Which is obviously right there in the 3rd rule. And then, do you see iron here? Because it's not a group 1 cation, it's not ammonium, Ca, Sr, or beryllium or anything, right? So it's not an exception, therefore it has limited solubility, which you can also just say as no solubility if you want. That's usually what teachers do. They don't say limited, they just say no solubility. And then sodium sulfide, is that going to be soluble or not? And then what rule does that go with? Does anyone know? Yeah, 3. Okay, and then anyone else? This is pretty easy, right? Like once you have the rules with you, it becomes really easy. Just like say yes or no, kind of like a checkbox, right? Yeah, it does become easier, yeah. So sodium sulfide. Do we have any other answers? So we have yes, and then number 3 again, yes, okay. And then anyone else? We all agree it's yes. Okay, so sodium sulfide is just Na2S, right? And then the rule that goes with that, again, number 3. And then exceptions include group 1 cations, right? And then Na is a group 1 cation, therefore, again, exception. So that, again, pretty easy, right? And then zinc oxide. What about that? What do we think? Is that going to be soluble or not? Yes or no? Zinc oxide. There's no ions in this one, right? So we're just looking at just elements alone. Is that going to be soluble or not? Does anyone know? Yes, no, I don't know. If you don't know, you can always just say I don't know, and then can also explain it. No. Okay, I don't know. No. Okay, zinc oxide. Are we gonna look at zinc? No, or because the rule 3 or O2. Okay, you're gonna be looking at oxygen, right? First, because that's one of the main things you see here, right? So zinc. I think you guys are confused on the formula. Zinc oxide. It's just Z and O. It's pretty easy, right? So it's oxygen. So obviously you're gonna look here. That's where oxygen is. And then do you have any of these in it? Group 1 cations or NH4? Do we have any of those in there? Zinc oxide. Do you see a group 1 cation? No. No, exactly, right? So it's gonna be limited solubility because it doesn't fall into those exceptions. And it has an oxygen, therefore it's limited solubility. So it would be no as well. And then are we okay with that? To understand that now? Zinc oxide? Yes, okay. And then do we have any other questions, comments, concerns, anything else? Anyone? Like if you have a question, if no, you can just say no as well. So, no. Okay, great. Then, okay, and then those are the answers. Again, you can also always say like, oh, not soluble or slightly or a little bit. Most teachers usually just put as no, but slightly also works as well. Okay, so precipitation reactions. Okay, so a precipitate forms when aqueous solutions of ammonium sulfate and calcium chloride are mixed. Write the net ionic equation for the reaction. So you're using a precipitate that we just went over, and you're writing a net ionic equation for the reaction. You're using ammonium sulfate and calcium chloride. So how do we do this? What does that look like? Does anyone know the formula for ammonium sulfate? Or if you don't know, you can write the first part, like, oh, I know ammonium, or I know sulfate. 4 plus 1. Okay, so that's part of the first part. Yeah. So that is the first part, yep. NH4. And then, does anyone know calcium chloride, what that looks like? What's that formula going to be? What does calcium chloride look like? Does anyone know? Yes, calcium chloride. Ca2. Yep, okay. Dolores, you might want to look back at that. I think you accidentally, yeah. Calcium chloride, yep, that's right. So those are going to be the reactants. No, you're good, it's fine. So what's our product going to be? Can anyone tell me? What is that going to be? Does anyone know? What's that going to be? What's our products? Because we have the reactants now. So what's our products going to look like? Oh, these typos are really great. CaSO4. Okay, do we have anyone else? What's another product? Or if someone agrees with that, is there anything else? For Cl. Okay, and do we agree with those? Like, we understood how we got those? Those products? Is anyone confused? Yes. Okay. Well, if you didn't know, by the way, it's just cations with anions, pretty much. So then it's just, so you guys would be right. It would be CaSO4 plus NH4Cl. And when you balance it, this is going to be 2. I'm not going to make you guys do that because that was like the other last test, so you probably won't have to do it very much. Yeah, but that's all pretty much. So which product is going to be the precipitate? Which one? Is it going to be CaSO4 or NH4Cl? Which one's the precipitate? Which one is it going to be? Can anyone tell me? The precipitate is always going to be solid. So which one of these is solid? The one that's not, yeah. The one that's not soluble. Ca? No. No? I don't. Wait, what? Okay, yeah, but precipitate, it pretty much just means, again, not soluble, which is why you're not going to break it apart. So do we have any other answers? Because I saw some Ca's and I saw no, so now I'm confused. So which one is it? Anyone else? I don't know. Well, okay, so if you're a little confused on this, ammonium is liquid. It's combined with chloride, it's going to become an aqueous solution. CaSO4 is actually going to end up being solid. And one of these has to end up being solid, right? Because then you have to do spectator ions and everything else. So this is the one thing that we're not going to break apart, that you can't make and break up into individual elements because it's precipitate, it's solid, you can't do that. So the rest of these, what are we going to do now? We have a precipitate, we have the products, what do we do? Can anyone tell me? What do we do next? Overall ionic equation, yes. So which elements do we break up, or which compounds? Or which one do we not? Can anyone tell me that? Which one do we not break up? Yes, exactly. So everything else gets broken up, right? So now we break this all down. NH4 plus SO4 plus Ca plus Cl2. And then we keep that one, right? So I'm not going to write that down because it's already intact together. So NH4 comes next plus Cl, right? So what elements can we cross out? Which elements aren't needed? Cl. Okay, anyone else? Anything else? What else is there? Just Cl? Or does anyone else have another thing they want to say? NH4? Alright, anyone else? NH4? Alright, so yeah, you guys would be correct. NH4, because you see on both sides, basically you're just crossing out. And those are the spectator ions because you don't need it anymore. So all that we have left is just Ca plus SO4 goes to CaSO4, pretty much. That's the only real thing that's there. And then you could always balance it out if you want. but it's already balanced. So, and if you want to put that little ion things on top, you can as well. That'll be 2 plus minus plus, and then this again, that's the precipitate, so it's insoluble, therefore it doesn't break down. Does that make sense? It's a solid, that's why it just stays the way it is, it never breaks up. So are we good on that? Yes, okay, great. And then, so that's how you write it out. If you're confused and you didn't get some of that, that's pretty much it. And then these are the oxidation rules, because we're about to go into that. So I'm going to go back and forth with this slide specifically so you guys can have it in front of you, because I noticed how difficult it is to remember the solubility rules, and I assume that you guys didn't memorize oxidation rules all the way yet. So we're just going to go back and forth with that. So oxidation occurs when an element blinks its electrons. What happens with oxidation? Can anyone tell me? It loses, gains. Oh, okay, so we have loses, gains, lose. Okay, anyone else? Loses electrons. Loses. Okay. I like how you corrected yourself. Okay. Yeah, it is lose, yep. And at first I understand it might be confusing, but just because it says reduction or reduce, so you would think, oh, it's losing electrons too, but it's actually oil, right? Huh? I don't know what that means, but yeah, reduction, you would think it's losing it, but it's actually quite the opposite, right? Actually, is a lot. Yep, it's pretty. Yep, that's correct. Again, it's just inverse of what you would think it to be. And then, speaking of which, what's the oxidation number, and how do you find it? So if Dr. Kelly were to ask a question on the test, and it says things like, well, how would you explain oxidation number? Like, what is that? Because everyone knows how to solve for it, but what is it? Can anyone tell me? I realize a lot of people tend to have problems with like questions like this. The charge of each element. Okay, not exactly. It has something to do with the charges and gaining and losing electrons. You don't know. Okay, does anyone else know? If you also don't know, you can write that as well. And subscript. Okay, alright. So, not exactly. So basic oxidation number, when it asks you, find the oxidation number of hydrogen or oxygen or FH, whatever, it's basically asking to find the number of electrons that an atom gains or loses when it forms an ion. So when that element forms an ion, how many electrons does it gain or lose when it has to form that? Kind of like a byproduct almost. And then how do you find it? I mean, we just saw it. It's pretty much the oxidation rules, right? For oxidation number specifically. So using that, what's going to be ClO3? What's the oxidation number? Can anyone tell me? Specifically, you have Cl first, and then oxygen. So does anyone know? Cl, what's the oxidation number?
2.
Yes, no, I don't know. Are we a little... okay, +2. Okay, do we have any other answers? He's like, yeah, that's fine, of course. Take your time. I don't want to rush anyone. You can just respond when you're ready. It's fine. But yeah, and then if you found that one, you can go on to OF2, oxygen fluoride, or hydrogen oxide as well. So you do all with the element you're going with. So Cl equals what? Oxygen equals what? And then that one as well. And then fluorine. Not sure. -1 + 5. Okay. Any other answers we have for part? Because we have all different answers right now. 2 Does anyone else +5? Okay. Let's go over this. Yeah, +5. Okay. So let's look at this. So first of all, what is this going to equal to? Is it going to equal to 0? -1. Yes, exactly. If you have an ion, it's going to equal to whatever the subscript is. And with ClO3, you see there's a negative sign right there. So it's going to be -1, right? And we know we have 3 oxygens. And then oxygen on the oxidation numbers is equal to what? Oxygen has an oxidation number of what? Does anyone remember? What is oxygen? -2, yes, exactly. So now you have -2 plus x. So that's -6 then. We're going to add that, right? +6 plus 6. So x equals -1 plus 6, which is equal to, what? What's 6 plus negative 1? Can anyone tell me what that is? 6 plus negative 1? Does anyone remember? 6 plus negative, yes, exactly. 5, yes, thank you. 5, exactly. So that's going to be Cl. That's how we got the oxidation number for that. Clarification. Oh, okay. Sorry. Yeah, then you would be right. The sum of the oxidation, yeah, is negative 1. Alright, I thought you meant that was for C. I was going to say, how did you get that? But okay. Then you're right then. Yes, it does equal to negative 1. And then oxygen, does anyone know what that would be? Well, actually, we already did it, so technically we know it's negative 2. Moving on then. Oxygen fluoride. What's the oxygen's oxidation number? Can anyone tell me? Yes, no. Plus 2. Okay, any other answers? Akash says positive 2 or plus 2. Anyone else? And then what's fluor? If you want, you can also say fluoride. Just verify that's fluoride, because I just realized I get confused. So, any other answers for oxygen? So Akash said plus 2. Does everyone agree? Plus 2. Okay. Then yes, you'd be right. It's plus 2. What about fluoride? What's the oxidation number for F? Negative 1, negative 1. Yes, that would also be correct. And do we all understand that, or do you guys want me to go over that? Because I think some of you guys didn't answer, so if you guys are a little confused, I can go over it. Yes? No? Yeah, of course. Okay, so this is just a regular neutral, just a regular compound, right? There's no ion, so it's just going to equal to 0. And because we know oxygen and the way it is, we know that because it's not always negative 2, right? We know it can always be something different. And we know fluorine right now, I believe, is negative 1, right? On the oxidation numbers, fluorine is negative 1. We have 2 of fluorine, right? So this right there, that's fluorine. And that's just a given. On any oxidation rules, fluorine is negative 1. We have 2 of those, that's negative 2, right? Plus x. So what's x going to be to get to 0? If we have negative 2 plus what equals 0? What's that going to be? What's x going to be then? Negative 2 plus what to get 0? Can anyone tell me what that is? So we can... Does anyone know? Are you confused on any part? Does anyone have an answer for that? Yes, no, plus 2, yes, exactly. So that's going to be this then. And then fluorine, again, that's just the negative 1 that we saw. Again, that's just part of the oxidation numbers. So that's pretty much that. What about hydrogen and the oxide here? So what hydrogen is going to equal? What is that going to be? Can anyone tell me on that? What's that going to be? Plus 1, negative 1. Okay, and then plus 1 again. Okay, so there seems to be a bit of differentiation in the signs. Okay, can I get another answer? So far, okay, and then plus 1 again. Alright, so let me look at this, because I know people think, oh, we're looking at oxygen first, right? But in actuality, we're looking at hydrogen, because oxygen, there's exceptions to that. Versus hydrogen, it only has an exception with a metal, and oxygen's not a metal. Therefore, hydrogen stays at negative 1. And negative 1 for that, we have 2 hydrogens, right? Yeah, it's alright, it happens. And then, because we have negative 2, we need it to equal to 0, right? Oxidation rules. Oh yeah, I'll go back to that in a second. But from this, you would know that negative 1 is the hydrogen. It only becomes not negative 1 when there's a metal included. Oxygen's not a metal, therefore it stays negative 1. We have 2 hydrogens, so it ends up being negative 2. It needs to equal 0, right? This isn't an ion, so it's going to be a 0. We have to equal it. So then, because we have 2 oxygens, negative 2 plus 2x equals 0. When you do that, side 2x divided by 2, that equals to be 1. Therefore, oxygen, but you need it to be negative. So hydrogen's going to be, again, both of them are pretty much 1 in a way. Hydrogen's pretty much negative 1, and then oxygen's 1. So I'm going to go back to the oxidation rules if you don't mind. Is that okay? Do you guys understand this? Yes, no, I don't know. Yes. Okay, so I'm gonna go back and yeah, so you guys can see all the rules. Again, oxidation number equals 0 when it's a pure element. Pure element just means like O2, N alone, hydrogen, like 5. Again, that's a pure element because it's pretty much just alone, so it's just 0. And then again, single atom, if it's just N, it's gonna be the charge of that. Also, they didn't write anything on here, but this is kind of just like something I saw, that if you have group 1 ions here, and then group 2 here, they usually match their number. Because I don't think you guys saw that, or maybe you didn't notice, but if you have NaH, for example, Na is usually going to have the oxidation number of 1. And then anything on the second one, like Be is going to be 2, because it's in the second row. So they don't write this on here, but I think it's very helpful to know. So, but it's not in your textbook, so that's why I wanted to explain it to you guys. So, are we good on this one? Yes? According to 5, what? According to 5, plus 1? Yes. Yes. I think I wrote that in my answers. Let's take a look. Yes, hydrogen's 1 and then oxygen's -1. I think I wrote it the other way, my bad. Oxygen's -1 and then hydrogen's 1. So, are you guys good on this section? Yes? Yes, no, I don't know. Because I understand that's a lot to remember. Yes, okay, great. And then is 1 or -1? There's an exception to it, I believe. So I didn't hear. Okay, so it's gonna be +1 then. Hydrogen +1. Oh, sorry, I put -1, but it's supposed to be +1 then.
Okay.
But it's essentially the same thing because they're both 2. So you have hydrogen and you had H2, O2. It would still be that plus 2x equals 0, right? And then -2 on each side. Then 2x equals -2 divided by 2. And then x equals -1. And that will be oxygen's oxidation number. Are we good then on that one? Yes? No? Yes? Okay, great. Awesome. Okay. So let's see what we have next. Oxidation reduction. Okay, I think we just did this. So if we have time, we'll go back to that. But for us right now, I really want to see like what else we had going on. Okay, let's see. Here, I want us to do this one. Alright. When energy released by the reaction of hydrogen and dinitrogen tetraoxide is used to orient and maneuver spacecraft and to propel rockets into space, identify the elements that are That's so much for Dr. Kelly. Okay. I mean, this is just one problem, so it should go by really fast. Are you okay with that? Yes. Okay. Because then it'll just be good practice. Then it's only one problem, I promise. So identify the oxidizing agent and the reducing agent. Because if you guys did it so much, then this would go by really fast, hopefully. And then we can get on to Kahoot and then other questions. So can anyone tell me what the... Oh, no. Okay, so what's the oxidizing agent here? Does anyone know? Oxidizing, as in we lose electrons. Losing electrons. Which two compounds lose electrons here? Can anyone tell me what that is? And then which one's gaining, as in reducing, right? So what's the reducing and oxidizing agent? And you could do this by eye, you have no idea. Okay. Anyone else have an answer? No, you don't know either. Okay. Anyone else? If you guys don't know, I'll just solve it as well, because if you guys are a bit confused, I can understand. Oxidizing and reducing agent. And by the way, I can guarantee you that you're probably going to have this sort of question on your exam. The identify oxidizing and reducing agent with like problems like this. So I think we have to learn how to do this part. Anyone else have an idea of what the oxidizing and reducing? Yes, no, I don't know. Again, if you don't know, you can just write I don't know. So anyone else? Reduce is N. Oh, is that what he was saying? N. Okay. Well then, reducing is N. All right, and then does anyone else have any other thing they want to say? And then what's the oxidizing? Because if reducing is N, what's oxidizing? Can anyone tell me what that would be? Yes, no, I don't know. Are you guys confused? If you're confused, you can just write it in the chat, like, oh, I'm confused, or I don't know. And then we can go over it. Yes. Oh. Oh, I'm confused. Okay, so let's just go over it. And I'm going to do it the mathematical way, just because I want you guys to have like a concrete understanding of it, versus me just saying how I would do it, like, oh, you just recognize it. Okay, so we're starting with N2H4. What's the oxidizing number? Or what is that going to be? Can anyone tell me? Does anyone know what that is? What's the oxidation number of N2H4? Yeah, that's right, but what's the full oxidation number? 0. Okay. Alright, yeah, that's right. Okay, so I was looking for something specific, but we'll get into that. So we know we have 4 hydrogens. It's not a metal, it's just nitrogen, right? So it's just going to stay 1. So we have 4, 1 plus 2 of X, which is nitrogen. There, right? So now we have 4 plus 2X equals 0. So X is going to equal what? I think Akash said it, but can someone else say it as well? Like if they know it. X is going to equal, what is that going to be? Solving this problem. 4 plus 2x equals -2. Yes, exactly. It's the same person. It's just Akash. Okay, so yep, that equals -2. And then, but when you put that all together, you do 2 times 2 plus 2 is going to be 8. So once you have this, what's the oxidation number of N2O4? Can anyone tell me that? Yes, no? Or you can do what Akash did and do individual elements. Like what's N's oxidation number, and then what's oxygen's oxidation number? Can anyone tell me that? What's oxygen gonna be? I think the oxygen's pretty easy, right? Because it's just a rule negative. You're still confused. Okay. So what we're doing first is we're taking the reactants and we're finding the oxidation number. That's the first thing we're doing. When we do this, we find that N is -2 and we find H is 1. And if we do the change in oxidation number, we can see that it's going to be 2 times 2 times plus 2. And that's going to equal 8. And then N2OH, what we have here, is that we know oxygen has, again, I think I caught it as well maybe, but -2, right? Oxygen's -2. And then you multiply that times 4, because we have O4, right? And then we're going to add 2x equals 0, because it's an ion. It's not an ion, right? So it's just going to be equal to 0. Once we do that, can anyone tell me what x is going to be on this one to find nitrogen? Can anyone tell me that? What's that going to be? Does anyone know? +2. Okay, any other answers? Because this is -8. -8 plus 8 is going to be 2x equals 8. We're solving for n right now to find the x for that reactant. 4. Yeah, it's fine. So x equals to 4. Yep. So when you do all this, and you do 2 times, now Akash, we're doing the full thing. So 2 times -4 equals -8. And that's for N2O4, right? So we have 8 going for that, and then N2O4 has -8. And now we're going to these two. Water, we're not paying attention to because that's just the gas. Like, we're not paying attention to that part. We're just paying attention to N2. So what's the oxidation number of N2? Can anyone tell me what that is? 0, exactly. It's a pure element, right? So if we're going from +8, which is 2N2H4, to N2, and you're going from 8 to 0, is that going to be going up or down? Are we losing or gaining electrons? From 8 to 0, down. If you're going down, you're losing, because it goes 8 to 0. You're losing electrons. The change in electrons is going down. So you're losing electrons. Therefore, it's the, what agent are we doing? Oxidating or reducing? 8 to 0. Can anyone tell me that? If we're going to 8 to 0, is that reducing? 8 to 0, you're going down. It's a loss of electrons. Oxidating, yes. I like how you said like both. It's a 50% chance each time. So yeah, it's gonna be oxidation. Do we understand that? It's going from 8 to 0. N2 is 0. You find the oxidation number of 2N2H4, it's 8. So 8 to 0, you're losing those electrons, it goes down. The other way. Maybe Dr. Kelly says a lot of things. I mean, if you want to learn her way and it works for you, that's fine. She does. She's sweet. I like her. N2O4, it goes from -8 to 0. So we're going up. If we're going up and we're gaining electrons, what's that going to be? Reduction. Yes, exactly. So do we have any other questions on this? You say it's 0. On that part? On 4. Okay, it's -8, actually, because we're doing 2 times -4. That's the change in oxidation number, by the way. The 8 and -8, that's the change in oxidation number. Do you understand that? Stephanie, if you're so confused, I can help you on that. Yes. So you got it. Okay. Kind of ish. Okay. Again, you're finding the oxidation number of all. You're finding the change in oxidation number. So it's going to be 2 times -4. I don't know how much sense I can make it other than that. But it's going to be 2 times you're just multiplying the changes in oxidation numbers. Because we have 4 up here, and then we have 2. That's why we multiply them. Do you get it? Oxygen has an oxidation number of -2. And then nitrogen has an oxidation number of 4. That's why you end up multiplying it in a way. Or you can switch it up if you want. You want to do -2, 4. It still equals -8. You're multiplying those 2 oxidation numbers. Are you okay? Are you good? Do you understand that? Okay. Practice it again. Yeah, again, like if you don't understand it now, you just have to keep practicing it. Practice makes perfect, right? And then this is what I was referring to. So it looks difficult like when I'm writing it out, but when you read it like this, it actually becomes really easy. So don't sweat it too much. It's not that much. You multiply it, not add it. Yeah, it's gonna be like right here. That's only for the change in oxygen reduction, or like the oxidation number, the change in oxidation number, because it becomes 2 times -4 to find 8. Again, that's a specific way of solving this. If you have a different way, or Dr. Kelly told you a different way and she likes it that way, then and it works for you, then you can add it if that's the way she told you. But I think this way is easier in my opinion. But again, whatever works for you. Are we good on this section? We're okay? Yes? No? I don't know. Are we alright? Okay. Alright. What's it called? Yes. Okay. By the way, here's the attendance link again, because I know some of you guys joined after. Here's the attendance link. So if you guys didn't get a chance, please sign it. Just let the SI program know that you were there. It's pretty annoying, I think. So, okay, that's there. And then let me see what else we have to see. Because some of this I think you guys already did. So I don't want to go over things I feel like you don't need to do. Okay, I think you might have to do this one because this is the question. I'll send this out, but you guys didn't learn this yet, right? Decay mods of radionuclides. You guys didn't learn that, right? Nope. Okay. Okay, so apparently it is on your test, which is really unfortunate because you guys haven't learned it yet. So unfortunately, I can't go over that. Yeah, I think I have another one. Where is it? Here. I don't have another oxidation reduction equation. I think I have it in the Kahoot. So I'll go over one of those equations again. If that's okay with you, Dolores. Is that okay? I'll do it in the Kahoot at 3 o'clock or something, if that's okay. Or 3:05. Does that work for you? Is that okay? Yes. Okay. So then let's go over a net ionic equation. And I'm not gonna do this one as much as I did the other one. I want you guys to go over it yourselves. So zinc metal and hydrochloric acid. Sorry, I can't speak today. Identify the oxidation and reduction half reactions. It looks scary, oxidation and reduction half reactions. I'll explain it, what that is, in case you don't know, but it's really easy. As of right now, just find the net ionic equation of zinc and hydrochloric acid. If you don't know what that looks like, that's the element for zinc and then hydrochloric acid. I think, I can't write on this computer, but it's HCl pretty much. So when we do that, what's it gonna look like? What's the products? Can anyone tell me? Zinc and hydrochloric acid. Does anyone know? What are those products gonna be? I mean, there's only one element for zinc, right? And then we only have two elements for hydrochloric acid. So does anyone know? There's only two products here. Can anyone tell me what those are? Zinc and hydrochloric acid. Just starting off small. So does anyone know what's gonna be? You don't know. Okay, anyone else? Can we help out the group? Or does anyone know like what the products are gonna be? There's only two possible answers here. I think it's ZH, but I may have mixed it up. Okay, does anyone else have an answer? Because Akash thinks it's ZnCl and then H alone. Does anyone else know or agree? Yes, no, I don't know. Anyone else? And again, some feedback. If you don't know, again, it's completely fine. It's fine to mess up and say you don't know. I think that's it. Okay, so yes, that's actually completely right. I just wanted to see if anyone else knew as well. ZnHl, and you know these gonna go together because it's Cl is negative and then Zn. You can kind of just go in and be like, oh, because it's a metal, right? It's a metal, and that gives you a cation with a negative. That's how you know it's gonna be together. And then hydrogen can just stay on the end, and then that's going to be your products, right? So once you balance that all out, you'll have two HCl on the side. Again, I wouldn't worry too much about the balancing. Well, now that we're doing the net ionic equation, what do we separate? Which elements? Or which one do we not separate? Can anyone tell me? Yes? No? I don't know. What are we gonna do here? Like, which elements are we gonna separate? Or which one doesn't get separated? I'll ask that. Which compound doesn't get separated? Does anyone know? Which compound? Yeah, okay, anyone else? Which compound does not get separated? Can anyone tell me? It's actually really easy once you see it and you realize you're like, oh man, because it's common sense, like once you realize it. Does anyone else have an answer? Sorry for the noise outside. ZnCl. Okay, actually that's a trick question. The only solid that's here is Zn. And why is that? It's a metal. It's a metal alone. Metal is solid, right? Like we know metal solid. Therefore, none of these compounds, hydrochloric acid, ZnCl, those don't break apart. The precipitate here, or the solid, is just the metal. That's all we have, yeah. Yeah, life's not fair. Anywho, alright, so now that we have that, nothing breaks apart according to any of those the small ones, right? So here, we're just gonna break it out. So we have Zn plus Cl, Zn again, because again, it's just one element, so it's already technically broken apart. And then, what do we do? Because by the way, that's H. And then we have Zn over here, plus Cl. What do we break apart now that we have all this? Can anyone tell me? What are we breaking apart? ZnCl. Alright, any other answers? ZnCl, Zn and Cl. Alright. Yeah, spectator atom, yeah. Cl, Zn. Okay, so I keep getting the same answers, and the reason, okay, I just want to say that you don't know everything. Alright, Zn, actually you don't cancel it out, because it's a solid. It's the solid, you don't cancel out the solid. Remember when we did the other ionic net equation, when it was the solid, that Cl, whatever, and it was solid, we couldn't cancel that out, because it's the solid. So this stays. Oh, yeah, that's why. I know, it's confusing because it's the reactants this time. I think that's why I wanted to put this equation so that you know it's not always going to be just one thing. So now that you have that, you have Zn. H actually ends up canceling out. I feel like you guys forgot about that. We have H on each side. And then Cl actually ends up leaving as well. So we have Zn, and it goes actually to just Zn, oddly enough, and then it has 2 electrons. That's pretty much it. It's kind of a weird equation, no? But do you guys get that? It's weird, right? Because you expect more on like the products, and it pretty much ends whatever you thought it was gonna be. So don't they have to share the coefficient or be canceled out? Oh, for this is if it was already balanced, which I had done in the beginning of Zn plus 2 HCl and then ZnHl plus H2, or this would be H2, pretty much if I were to like balance it out. But if the elements are the same after you balance it out, everything like which I had like technically already done, then it would be fine. Then you'd be good. But it's just Zn to Zn plus 2 electrons. Are we good on this? Yes? No? We're good? Yes? If you're not, okay. Okay, great. So what I'm gonna do now is actually 2 electrons. That, you don't have to worry about that too much, Stephanie. It's just there to be there, kind of, as just like electrons that were passed over. Because Zn is the precipitate this time, or it's just the solid in this case, because everything else is aqueous or liquid. That's why, or a gas. It's not solid. So that's why 2 electrons, I wouldn't worry about too much. As long as you know Zn goes to Zn, you're fine. Are you done on that? Yeah, great. Okay, and then here's the work for it, if you were confused. And then, by the way, the half reactions, I don't think she's going to ask you on those, but in case you really wanted to know, it's just Zn to Zn, same thing. And then over here, that. So, are we okay on this? And that's the oxidation. So, are we good on this? Yes? Okay. As of right now, this is the part where we have a break, because then after this, we're doing a Kahoot. So, you can take this time to like